My dear students, in the previous video, I have solved some problems in the exercise 13.1, and in this video also I am going to continue the same exercise 13.1. In the exercise 13.1, problem number 24 is find limit x tends to 1 f of x, where f of x is given by x square minus 1 when x is less than or equal to 1, minus x square minus 1 when x is greater than 1. This is the definition of the function f of x. For that, first I am going to find limit x tends to 1 minus negative side of 1. F of x is limit x tends to 1, negative side less than 1 is x square minus 1, less than 1 is f of x is x square minus 1. Therefore, this is x tends to 1 square minus 1, 1 minus 1 is 0. Similarly, right side of 1, limit x tends to 1 plus f of x. 1 is x is greater than 1, 1 plus. The function limit x tends to 1, 1 plus is minus x square minus 1. Replacing x tends to 1, minus 1 square minus 1. Minus 1 square is minus 1 minus 1 minus 2. This is not minus 1 whole square, it is just minus 1 square. Minus, you are not supposed to think this is minus 1 whole square, it is just minus half 1 square. Therefore, 1 square is minus 1 minus 2. Therefore, limit x tends to 1 minus f of x is not equal to limit x tends to 1 plus f of x. Therefore, the left and right limits are not equal. Therefore, the limit x tends to 1 f of x does not exist. That is the problem. In the 24th problem, limit x tends to 1 f of x does not exist. Come to the 25th problem. Evaluate limit x tends to 0 f of x. Here also f of x is defined by modulus of x by x when x is not equal to 0, 0 when x is equal to 0. The definition of mod of x is minus x when x is negative. If mod x is x, if x is positive. Modulus of x is minus x if negative of x. Modulus of x is positive x if x is greater than 0. So, you apply the limit x tends to 0 minus left side of 0 f of x is limit x tends to 0 mod x by x. Left side of 0 is x value mod x value is minus x. Therefore, minus x by x is minus 1. Similarly, right side, limit x tends to 0 plus we will see. Limit x tends to 0 plus f of x is equal to limit x tends to 0 mod of x by x. The positive value of x mod x, if x is greater than 0, modulus of x is x. 0 plus positive side of x mod x is x by x, that is equal to 1. The limit x left limit is not equal to right limit. Limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x, because this is minus 1, this is plus 1. They are not equal. Here also, limit x tends to 0 f of x does not exist. In this problem also, the limit does not exist. That is problem 25. Similarly, the 26th problem, with the same type you have to solve. 26 also, find limit x tends to 0 f of x, where f of x is defined by x by mod x, where x is not equal to 0 and 0 if x is equal to. In this case also, as in the case of the 25th problem, mod x by x is rewritten as x by mod x. Here also the same definition, mod x is negative x if x is negative, mod x is positive x if x is positive. Apply this type of the same left limit and right limit for this problem also. We can see the two limits, left and right, are not exist. Therefore, the limit extends to 0 does not exist for this problem also. You try to solve the 26th problem by yourself. Next I am going to solve problem number 27. The same method you have to solve. 26 you apply the same method we adopted in the problem 25. Okay, next problem 27. Find limit extends to 5. Find limit x tends to 5 f of x. Find limit x tends to 5 f of x, where f of x is mod x minus 5. Here left limit of 5 and right limit of 5 have to determine. First limit x tends to 5 minus f of x is equal to limit x tends to 5 mod x minus 5. Since mod x is greater than 0, this is mod x is 5 minus 5 is equal to 0. Similarly, right limit x tends to 5 plus f of x. In this case also, limit x tends to 5 mod x minus 5. So here also modulus of x is positive side of x because we are dealing about 5. Limit 5 is greater than 0. Here also greater than 0. Greater than 0 mod x is x. Therefore, this is x minus 5. You can write limit x tends to 5. You can write limit x tends to 5. Mod x is 5 minus 5. So that is 0. Similarly, here also limit x tends to 5. Mod x is greater than 0. Therefore, this is 5 x minus 5. Here also you get 5 minus 5. You will get 0. Therefore, right limit will be equal to the left limit. Therefore, limit x tends to 0, 5 minus f of x is equal to limit x tends to 5 plus f of x. They are equal. Therefore, limit x tends to 5 f of x equal to 0. That is your answer. Exists and the value is 0. That is the problem. Find limit x tends to f of x is 0. Next problem number 28. Simple problems. Modulus of x is both the cases, since it is 5 greater than 0, you will get positive x only, therefore you will get 5 minus 5. Left and right limits are equal. Therefore, the limit x tends to 5 f of x is 0. Next, problem 28. F of x is defined by a plus bx, a plus bx if x is less than 1, 4 if x equal to 1, b minus ax if x is greater than 1. And also, if limit x tends to 1, f of x equal to f of 1, it's also given. What are the possible values of a and b? You have to find out the values of a and b. F of x, limit x tends to 1, f of x is f of 1. So f of 1 is, you know, x equal to 1, f of 1 is 4. That is equal to 4 given. If x equal to 1, the value of the function is 4. Therefore, f of x is 4. First, left limit x tends to 1 minus f of x is equal to limit x tends to 1. Left side of 1 is less than 1 is a plus bx. After applying the limit x tends to 1, a plus b, x tends to 1, a plus b. Similarly, limit x tends to 1 plus right side of the limit f of x is greater than 1 is b minus ax. So, limit x tends to 1 plus b minus ax. In this case, if you substitute x tends to 1, this is b minus a. This is right left limit and this is right limit, and these are equal because f of x is exist. Since a limit x tends to 1, f of x exists, that is f of 1, we say that limit x tends to 1 minus f of x is a plus b, that is equal to 4 because left limit equal to right limit. Similarly, limit x tends to 1 plus f of x is also b minus a. This is also 4 because left limit should be equal to right limit because since f of x exists, left limit and right limits are equal. Both are equal to the value 4. Solving these equations, a plus b equal to 4 and b minus a. b minus a equal to 4. Since these two limits are equal because limit x tends to f of x exists, left limits and right limits are equal, and left and right limit values are equal, both are equal to 4. Adding plus a minus a, 2b equal to 8, b equal to 4. Substitute the value of b in the equation 1. A plus b equal to 4, a plus 4 equal to 4, and a equal to 4 minus 4, and a equal to 4. Left side, if you bring this minus 4, this is 0. So a equal to 0 and b equal to 4. That is the problem. What are the values of a and b? We determine a equal to 0, b equal to 4. That's all about the problem 28. Next, simple problem 29 we will see. Let a1, a2, etc. an be fixed real numbers. A and be fixed set real numbers. A1, a2, etc. fixed real numbers, and f of x equal to x minus a1 into x minus a2 into etc. x minus an. This is f of x. What is limit x tends to a f of x? What is, first question, what is limit x tends to a, x tends to a1, limit x tends to a1 f of x. This is our first question. What is limit x tends to a1 f of x? Apply the limit. Limit x tends to a1 f of x equal to limit x tends to a1 f of x is x minus a1 into x minus a2 etc. into x minus an. Apply the limit x tends to a1 here. You will get, applying the limit, x is a1 minus a1 into a minus a2 etc. into a minus an. Since a1 minus a1 is 0, 0 into everything is 0. So limit x tends to a1 f of x is 0. Second one is, for some a not equal to a1 etc. a. Second question. For some a not equal to a1, a2 etc. an. For some a not equal to a1 etc. an, compute limit x tends to a f of x. Compute limit x tends to a f of x. It is simple. Limit x tends to a f of x equal to, in this step, I can substitute limit x tends to a f of x is x minus a1 into x minus a2 etc. into x minus an. Substitute x for a, you will get a minus a1 into a minus a2 etc. into a minus an. That's all about the problem. Limit x tends to a f of x is a minus a1 into a minus a etc. a minus an. Limit x tends to a1 f of x is 0. These are the two problems. That is problem number 29. That's finally the last problem, 30th problem. No, sorry, 31. We will see the problem between 30 and 32. I omit those two problems. Now I am going to solve the problem number 31. Problem 31. If the function f of x satisfies, if the function f of x satisfies limit x tends to 1, f of x minus 2 by x square minus 1 equal to pi. Evaluate limit x tends to 1 f of x. From this, evaluate limit x tends to 1 f of x. So from the problem, limit x tends to 1 f of x is f of x minus 2 by x square minus 1 equal to pi given. By cross multiplying, limit x tends to 1 f of x minus 2 equal to pi into limit x tends to 1 x square minus 1. By cross multiplying, taking limit both in the numerator and in the denominator separately, numerator limit is limit x tends to 1 f of x minus 2 equal to pi is already on the right hand side. Cross multiplying the denominator limit, limit x tends to 1 x square minus 1. What do you get? Limit x tends to 1, f of x minus 2, you write as it is. Applying the limit on the right hand side. Limit x tends to 1, f of x minus 2 equal to pi into limit x tends to 1. Apply limit for x square, 1 square minus 1. 1 square minus 1 is 1 minus 1, 0. Pi into 0 is 0. Therefore, limit x tends to 1, f of x equal to, you bring this minus to the right hand side, it becomes plus 2. That's all about the answer. Limit x tends to 1, f of x is 2. That is the problem 31. That's all about exercise 13.1. We will see the next topic in the next video. Thank you.